Hello, my friends. I wanted to do this two-way table problem where you assess the association between two categorical variables. And in this problem, actually we did it sort of as a quiz in class or something. It's in the workbook on page 268, I believe. Okay? And so there's a lot of text to read, so I just want to skim through it and pull out the most important parts of this text. The table summarizes the results from an observational study that followed a random sample of 8,474 people. Okay, so there's a total of this many people, and that's right here in the bottom corner. That's everybody. 8,474 people. All participants were free from heart disease at the beginning of the study. The variable anger categorizes participants as low, moderate, or high anger based on the Spellberger trait anger scale test, which measures how prone a person is to feelings of anger. So this is just an anger test. Okay, that's all they did was just test how angry people were. Okay, and then we're relating that to CHD, coronary heart disease, CHD, which is a count of the people who had heart attacks or needed medical attention for heart disease during the study. Okay, wow. So I think what's going to happen is we're going to associate anger as the explanatory variable with coronary heart disease, so that's going to be the response variable. Okay? Now, does this data suggest that there is an association between anger and heart disease? I think that means that we were right, so that anger is going to explain heart disease. The angrier you are, do you have more heart disease? Well, that's going to be not hard for us to do. What we need to do is we want to know the probability of having CHD. In this case, that's a negative outcome. So it's the risk of developing heart disease given that you have low anger. I think we're going to compare that with the probability of having CHD given that you have moderate anger. So sort of medium anger. Or if you were a very angry person. So the probability of having CHD given that you were high anger. Okay? And now the table's already set up for us to do this. If you remember, this explanatory variable tells us the denominators. So I'm just going to write those denominators in. Low anger, right? That's going to be these people. Of all these people, how many of these low anger people had heart disease? That's going to be 3,110, right? For the moderately angry people, it's going to be 4,731, right? So we're saying of all these moderately angry people, how many had heart disease? And then the last part is to say if you were very angry, a high anger person, and that was not a lot of people comparatively, but there were 633 of them. What is the chances that you ended up with heart disease? Well, we basically end up taking all of these heart disease people and we divide them by how many are in each of these groups. Right? So there were 53 low anger people who had heart disease. So let's calculate that. That's 53. And then there were 110 moderately angry people who had heart disease. And then there were 27 people with high anger who ended up with heart disease. Okay? So what is that? What are each of these percentages? Well, I have, if I take out my trusty calculator here, oops, didn't have my calculator ready. I gotta do 53 divided by 110, 53 divided by 3110. Oh, I get, this is about 1.7%. 110 divided by 4731 is going to be 2.3%. And then, oh, wait a second. The last thing then is 27 divided by 633, and that is 4.2%. Okay, so these, you can see that the percentage of people with heart disease increases as your anger increases. Okay, use the method of your choice. So the high anger versus low anger. So we end up with, I like to do times more likely. So high anger people is 4.2%, divided by the low anger people is 1.7%. That equals 2.47. So that means that people with high anger are 2.47 times more likely to develop heart disease than low anger people. That's really not the best grammar, but that's what just came out right now. So there you go. Remember, whenever we're finding an association between two categorical variables, we have to use these conditional probabilities where it's the probability of the response, particularly if it's a risk, then we look at the negative outcome of the response. In this case, the response is developing heart disease, given that you pick different values of the explanatory variable. Because we want to change the explanatory variable to see if this response changes. Okay, hope that helps.